Hello again, John here, and in this tutorial, 19 I think it is, of the machine code 6502 programming, in the last videos we did an overview of the kernel jump vectors. So in the next couple of videos we're going to do a deep dive into some of the kernel jump vectors that I have used before. Now in this tutorial we are going to be using the output jump vectors, and the jump vectors we're going to use is character out, channel out, open, set logical file system, set name, clear channel and close. So just as a reminder, so the character out is using jump vector ffd2, and this outputs a character from the accumulator to the channel that we've activated, and the preparation routines are normally open and character out. Channel out is a routine that configures the channel in the 64 to be in output mode, uses jump vector ffc9, which is an address vector in memory which you can override. This takes the logical file number in the X register and returns a number of error messages which we've talked about before. And the A and X register are the only two registers that are affected during this routine. The open jump vector, which is ffc0, opens up the logical file to be used by the computer. This has a number of errors which we will look into when we do the tutorial. But it needs to perform the open. You need to prepare the logical file system and to set the name of that particular file number. There's no communication registers, but all three registers are affected when you use this command. Set logical file is jump vector ffba, and this allows you to set up the logical file number. So we set up the file number, what the device address is and what the secondary address is, and all three registries are used to prepare this function to work. The next one is set name. This sets the file name if you was using a disk or a tape or anything, but on other certain devices you don't need to set up a name, and we'll go into that in the tutorials. It uses the X and Y register to address with the file name, and the accumulator is the number of characters in that file name. By the way, that jump vector is ffbd. Then we've got clear channels, and this basically just clears all the channels. So it resets, puts the input-output channels back to the defaults. That is jump vector ffcc. And the last one that we're going to be using is the close, which basically does the opposite of open. It closes the logical file number. Using jump vector ffc3, you communicate it by the accumulator. You put the file number into the accumulator and it will close that file number. Now all these 6 or 7 jump vectors will be the standard set of jump vectors if you want to talk to, say, the disk drive or the printer or the tape. There's no other jump vectors you need to use, and all we're going to do is we're just going to send some text to the devices and see what happens. So we'll come to the code, and here we go. So we're in Program Studio. I'm just going to close a couple of these because we don't need them. So tutorial 19, written by me, created today, and what we're going to do is we've set up the jump vectors as variables, and also I've defined another variable called print string, which is at location AB1E, and this is an inbuilt function within the Commodore 64 that allows you to print a string that terminates in a 0 value, and you can find the information for this address in this book, The Anatomy of the C64, and it's on this page. Now I've highlighted the bit that's required, so it's page A23, and this is just the code that allows it to print a string to the channel in its current state. So back to the code. So here we go. So I've just created some basic code. So I've got a test file name called John Test. I've got a test file name disk, because when we talk to the disk we have to add extra parameters into the file name. So basically this is the same as the test file name, but we're telling it we want to be a sequential file, and we're going to be writing to the disk because it's an output, and this is what we're going to send out as the text. So we've got a routine that prints to default. Now if you remember in the videos before, when you print to FFD2, it will print to whichever channel that is currently available at the time. So if you've not set up any channels, then it will always default to the screen. So if you print a character using FFD2 and there's no channel set up, it will print it straight to the screen, and that's what this example is there to do. It's basically we've not set anything up, and we're going to print the string and see what happens, and it should print to the screen. Now, and we've got another routine here which is to print to the printer, and what we're doing is we're doing the first thing, which is set logical file system. So we're going to load 4, which is the logical file number we want to use in this particular instance. I'm transferring the accumulator into X, so 4 is going to be the device number, which happens to be the printer, and I'm going to set a secondary address of 255. Doesn't matter for the printer what the secondary address is, because it never uses it anyway. Then we call the set logical file system, and then the next thing we have to set is set the name. Now with a printer we're not going to be sending it a file name because it's a printer, we just want it to print. So we just do the defaults, which is 0, 255 and 255. Then we perform the open, so now we open the file number, and then we set the channel to go to be in output mode for the logical file number 4, which is the printer. Then we're going to just do the print like we did with print default, and to be honest I could actually change it to be like this, so JSR print to default, and just clear that out. And in fact I'll do that for all of them. I think that's a good idea. So print the string, there we go, print to default, and it's just to show you that print to default, there we go. It's just to show you that even though we're saying print to default, the default is actually now, in this particular case, the printer. Then once we finish, we clear the channel, and then we close the logical file number 4, because that's the one that we opened up to start with, and then we return back. The next routine is to tape. So we're going to open logical file number 1 this time. do exactly the same, transfer A into X, so logical, so file number 1 is the tape. Do the same with the secondary address, 255, because it doesn't really matter, so we set the logical file system. Now, with a tape, we do need a file name. So the file name is test file name, which is up here, and if we count, we've got 8 characters. So we have to tell it that its length of 8 characters, and then that's the lower byte reference of the file name and the upper byte reference of the file name, and then we set the name. Then we open it, then we say set file logical file number to be the output channel, then we're going to do the print default, then we're going to clear the channel, and then we're going to close logical file number 1. And for print to disk, it's exactly the same thing, but we're going to open up logical file number 8, transfer A into X, which means use drive 8, drive number 8. Oops, I put printer there, and it's not, it's disk drive 8. We're going to tell it that we want secondary address of 2, because if you remember when I talked about it before, it was between 2 and 14. Set the logical file system, and then we have to use a different file name, because this is the file name we're going to set up, but we're going to tell it it's of type sequential, and we're going to write to it. So that's 18 characters altogether. So I'll put 18 in there, told it where the logical low byte is and the logical high byte of the file name is, set it up, open it up, and then set the channel out to logical file number 8. Then we print the default again, then we clear the channel, and then close the logical file number so it's not left open. And as you can see, we've got no error trapping whatsoever at the moment, but that's going to come later on when we start messing around. And what we'll do is we'll probably do it on here in this routine, because it's easier to emulate the disk than it is to emulate a tape. Alright? Right then, so we're going to run these examples one by one. So the first thing I'm going to do is show you exactly what happens if you want to output those characters without setting up any channels or any file numbers or any devices. So here we are. We're just going to run the print default. So here, going to assemble it. Looks okay. There we go. So this is the Vice emulator, and the reason why it's just because we put it in a different place, because I didn't want it to run every time. So we're going to fire it up from where it is. So this should just display the text to the screen, which it does. And the reason for that is because we didn't set up any output file number or channel, and so the 64 is just immediately assumed that any output that you're doing is going straight to the screen. So the next one we'll do is the printer one. Now this is going to be a bit tricky, because we have to set up a printer every time we run the Vice engine. So we'll assemble it again, fire it up. So let's just move this down here. So here we go. So we're going to set up the printer. So we're going to turn it on, yeah, and we're going to make it emulate an MPS 03, and we're going to put it in the root directory, the output. So that's now emulating a printer on device 4, which is what we've set it up to be. So we'll fire it up. There we go. So if we go to the C drive, refresh, there we go, 4 kilobyte file, and we open it with Notepad or something like that. We'll do Visual Code. There you go.
And as you can see, because I emulated the MS-01, it's done it as it would dot matrix printed out. So this is to test. And if I scroll along, let's make this box a bit smaller. Make it fill the area that we've got. This is to test the output jump vectors. Yeah? And you can just see a thumbnail of it. So that is successfully printing to the printer, but because the emulator is dumping it to a file. Alright? So the next thing we're going to do is we're going to send it to tape. So I'm going to create a tape. I'm going to assemble this, and when the emulator fires up, here we go, we're going to attach a tape image. So there's my tape, and just for completeness, it's an empty image, nothing there. So I've now got a tape attached to the emulator, so I'm going to run 96.9. I'm going to run the output, so we're going to create a file on the tape with that text in it. So there we go, press record and play. So tape controls, record, so off it goes. Oh, the bad old days of waiting for a tape to work. So hopefully this will come back pretty quickly. There we go. So that has now saved that text in a file in that image. So if I look and try and find it, there you are, my tapes. Try and open it, there you go. So that has been populated, and we'll look at that through the emulator, because I think that's probably better. So if I do file, attach tape image, just click on it. There you are, John Test, and it's a sequence file on that image. Right. So the last thing is to do it to disk. So we'll just rem out that one, and so we're going to do exactly the same thing, but we're going to do it to the disk. So it's going to create a file called John Test. It's going to be a sequence file, and but we just still have to set up the emulator with a disk. So we're going to attach a disk image, and where's my test one? Test disk. Oh, it's got John Test already on it. Can I delete it? No. Right. So let me just open up that test disk. Yeah. Get rid of it. Leave it there. Save it back. Go back into the emulator. Mount the disk images, because we didn't do it. So as you can see, John Test is not there, so we're going to attach it. So that's attached the disk image, so we're going to run it now. 496.9. There we go. Now that should have saved that text to here, so we're going to double it again. Okay, there it is. And if we double it, there you go. Inside it says this is to test the output of the jump vectors. So in this small tutorial, we are using 2, 4, 6, 7 jump vectors and a routine in the basic, and I'm demonstrated how we can output information to either the screen, to the printer, to tape,
or to the disk. And they're the four main output devices, and it's as easy as that. There's no magic to it. It's just looking through it logically. Now I'm just looking at the clock, and we're currently 20 minutes into this. So what I'm going to do is I'm going to call it a day for this video. But what we're going to do in the next video is we're going to put some error trap into the disk one, because it's easier to simulate, because we'll have, we've got a disk image with the file with the same name, so we can test that the file already exists. We can also test that the device is not ready, or if the disk is in, or anything like that. So in the next video we're going to put some error trapping in, just to make it a bit more resilient, and to let the user know there was a problem at that particular time. So until then, I will see you later. Take care. Bye.